Gandhiji, are you there?
Yeah, I'm there. Namaste to all. This is the course on Sanatana Dharma for youth. Today's class will be by Dr. Goutham Mukherjee. He is a great teacher, and the subject is Vedic Maths, Introduction to Vedic Maths. Dr. Goutham Mukherjee is an academician and he's had work experience working with NIC. He did his MSc in physics from Burdwan University, West Bengal in 1977 and his PhD in physics from the IIT Kanpur in 1986. He joined NIC, National Informatics Center, in 1990 and retired in 2016. He was holding the post of Senior Technical Director then. All through, he has been interested and worked on learning and being a Sanatani. He is a Sanatana Dharma student. He is interested in Vedic maths, has done a lot of work on it. His classes are extremely interesting. I speak for as a student who has enjoyed the sessions. We will start the class with Prarthana from Aditi.
Sarve bhavantu sukhinah, sarve santu niramayah, sarve bhadrani pashyantu. Sorry. Shuklam Varadara. Sorry, 1 second.
Continue, Aditi. Tuambara Dharam Vishnu, continue.
Sorry. Shuklam Varadaram Vishnum Shashivarnam Chaturbhujam Prasannavadanam Dhyaye Sarva Vignopashantaye Saraswati Namastubhyam Varade Kamarupini Vidyarambam Karishyami Siddhir Bhautame Sada Hari Om Shri Gurubhyo Namaha. I'm so sorry.
Mukherjee, this is a level 1 or level 2?
This is level 1 and it is and level 2. Same presentation actually. In the same presentation, I put level 2 in the last few slides are of level 2. That's what I didn't change the whole all over the whole presentation. Initial slides are all level 1.
But this is being recorded as level 2. Recorded as level 2. No, that's why I'm saying.
Oh, it will be recorded. Actually, this particular is not getting, not allowing me to edit. Maybe I cannot edit it.
Delete this slide. Don't present this.
Yes, editing is it is not allowing me to do edit. It's not being because actually this is my son's laptop and I don't know. I'm
proceed.
Okay. Yeah. So this is about the introduction of Vedic mathematics. It's only level 1. Start with. So my numbers and are there. Now, how the concept of counting has started. Original counting is that by putting some lines, and then there are 5 lines. After 5, there'll be one horizontal line, so that blocks of 5 are understood. So, Babylonians had some concept about something like 100,000, etc., but not very profound number system was developed there. Roman number system we sometimes use. Those are used in a particular fashion. These are only a few letters, English letters I, V, X, L, C, D, and M, with which their particular values are there, and they write those things. But those are used as an ordinal number, labeling something, not as per calculation. Now, cardinal and ordinal numbers, you can here. There are 2 ways of usage of numbers. Cardinal number is that one that is it is only number is there, cardinal numbers, and ordinal numbers are there one which is the first, second, third, fourth, etc. There no calculation involved, only position value is there. Something, some numbering of a particular leveling something. So mathematical calculations can be done on cardinal number only, or not on ordinary numbers. Now, the positional number system of India. This is the profound number system came only with the in Vedic times maybe, but we exactly do not know. But in a known history, we have seen that Aryabhatta used 400 AD. He used this positional value systems, and this positional value system became the dominant system. It replaced all other systems throughout the world, and gradually, actually, first in the Arab countries, this from India, they have the positional number system went actually, but English people, Europeans picked up from Arabians, so therefore they are named as Arabic number system still. Now they are actually gradually modifying, and they are telling as Indo-Arabic number system. It is known as that, but actually originally it is Indian. But people tell that what is discovered in number system, people tell that is zero was discovered. But as I discussed here, the zero is actually a corollary in the positional number system, because when there is no digit, so you cannot write anything between 1 to 9, because that particular place is, suppose the decimal, dasak. Oh, okay, the unit and the tens. Tens is absent. How do you represent it? You cannot combine the other digits. You have to keep a gap. So gap was put by originally a circle. Circle was given there to the gap. That gap became gradually it was converted into zero. That round system, round circle was taken as zero. So ultimately what happened? This is very important. Number of symbols became equal to number is the base, that is 10. 10 is the base. So 10 digits number. Then zero was put as a part of calculation by Brahmasputra Siddhanta and Brahmagupta, by Brahmagupta, and later negative numbers, all these things are also discovered. There is a Mahavir was there in 1830 who wrote Ganita Sara Samhita, and then gradually by Bhaskara in 1100, gradually zero became had a position, has a place in the calculation also. That what to these four formulas, as you see, these are for that some subtracted, what to subtract the same result, and square root of 0 is 0, and also this formula came later. Now base is very important in the base value system. We from our childhood we learn the decimal base, that is a base with 10, because it is understood that maybe originally it was found to be more considered as the more original, most original, because you have 10 fingers. So people used to first count things in finger, and gradually it became sort of decimal system dominated everything. But other systems are also possible, that in computer, because in computer we cannot have the 10 levels of a voltage or current or anything. Very difficult. So there are only 2 levels called switch off and switch on. Suppose you have simply electrical switch. Sorry, it can have only switch off and on condition, 2 conditions. So that 2 conditions became 2 states of a digit. One is represented by 0, another is represented by 1. So therefore, for computer, binary having only 0 and 1 became the most natural number system. Okay. But when binary is grouped into 4, this became hexadecimal. And so hexadecimal, how to, number of digits will be required as 16. There are 0 to 9, and then A, B, C, D, E, F. These 6 alphabets are used. Now, positional number system, we know the concept of place value and face value are there. That somebody in this 756, the 7, 5, and 6. These are the face value, and their particular unit 10, 100. These are called place value. So this, when you multiply these things, it becomes the, and add, that becomes the number. And negative place value. Actually, negative not. You can say that actually negative position of the place value. It is actually fractional. So 10 to the minus 1, 10 to the minus 2, etc. So 0.34. So this was actually later modification, but negative face value are not used. That is called vinculum, that we use in this Vedic system. Negative face value is also used. So negative face value is decimal points. We all use it, but negative face value we do not use that much, but used in Vedic mathematics. Now, there are actually, this is slightly not related to here. This is about the different symbols that is used in India and or other countries. You can see that there is something called hex code. But there is detail about those are interested in computer system. That is for them, not for all the people. So you can go through it later, and by going through this one, you know that Tamil, Telugu, all these things have particular numbers. The number symbols are all written here. Bengali, we know that is our Bengali letter. Hindi is there, and so on. Those have particular way of using in computer. That is a separate question. Similarly, in outside India also there are so many. Now, Vedic mathematics is what? What is now? I come to Vedic mathematics now. Vedic mathematics is there are 16 Vedic sutras and 13 corollaries or sub-sutras. So these actually Vedic mathematics procedure gives alternative procedure, so that same problem you tackling in different forms gives you more strength on the number system. You give numbers become very easy to grasp for you, and you know that you develop intuition, so that in which particular case, which particular position, a particular method will be applicable, that will be clear too. And this Vedic mathematics book is very important. One can purchase it. I think Shogunji must have a copy of this by now. It is cheap actually, 225 or something like that. It can be ordered through Amazon. Now this is a photo taken from there, a scan copy of that from that book. So the 16 sutras and 13 sub-sutras. And you can go through these things. We'll be using.
மின்னணி என்கிட்ட அனுப்பினி எனக்கு படிப்பிச்சு தானே சொன்னது.
One more than the previous. And all from 9 and ultimate from 10. This is the meaning of Nikhilam Navata and Charamodasuta. Urdha Trijagabham with upper slant. These things we will be using, transport and upper. These 4 actually very important. We will be using, and there are other for very advanced kind of calculations are there involving this for calculus. So there are advanced calculations are there. We do not go through that. We only will be discussing only these 4. Nikhilam Navatas Charamodasuta, Urdhva Trijagabham, and Paravartya Yojayit. Okay. So you can go through this thing. Now, what all can be done is, these are the scope of Vedic mathematics, all the different higher kind of, there are very basic arithmetic computation can be done, multiplication, division, these things. Now check the divisibility, Then there can be square root. These will be on the second level, of course, and factorization also is on the second level. Now, arithmetic computation. Actually, from our childhood, we always learn a particular, only one kind of addition, one kind of subtraction, one way of method of multiplication, one method of division, and so on. But there can be, and there is an algebra behind that. Some algebraic background there for the procedure we write. If we change the algebraic background, the procedure also will be changed. And you have to practice the procedure. Like we have practiced that from childhood, similar, the effort should be there for learning a different procedure. We will be showing that. And we do not always, we need not always map with our learned procedure. We have to totally change the mental framework and the mental framework for learning the procedure so that your procedure becomes very easy and straightforward. And I repeatedly again I read that actually the vinculum I earlier mentioned negative phase value. So here, if something is more than 5, we can write like 48, 8 is more than 5. We can write like this 5 and 2 with negative symbol here. The vinculum negative symbol is made on the head of that and above that. So it's a minus coming on the left, it comes above. So that is 5 and 2. So that 5 and negative 2. So it becomes 50 into minus 2 into 1. And unit is minus 2. So that 50 minus 2 is 48. So this way we practice like that. Vinculum. Vinculum will be coming discussing again and again. And here this Nichilam Navatastarvam Dasutta is used very much. Like for 97, we write 100 minus 3. It is 1, 0 and negative 3 vinculum. 143, 143 negative means actually here Nichilam Navatastarvam Dasutta. Last one we subtract from 10. The 10 minus 3 is 7. And other side subtract from 9. 9 minus 4 is 5. 9 minus 1 is 8. And when we are going from negative to this vinculum to non-vinculum, this where the vinculum ends, that has to be reduced by 1. 143. Actually, basically, concept behind is this. It is basically 143,000. You are subtracting 143. So what we do? We do like that. Last one we subtract from 10, and then we always something like lent and borrowing and something like that. So in that procedure, we know that we are subtract from. If there above is 0, we have subtract from 9 basically effectively. So this is this procedure is described in a different format, and we also know that in the last this becomes 3, which will become 2. So this is not much different, not much difficult to learn. With vinculum, we can use only up to 5 into 5 table will be sufficient. Now the addition, how can it be done? The addition with vinculum. You can see that this is converted into vinculum. I will not go into much detail. These are all greater than 5. So convert these things, and it is seen that by doing so, your addition becomes here. There are not many. You have to keep lot of carries that will be involved. Here, less carry will be involved. You know, this becomes that if the state without any carry, it becomes minus 8. It's minus 2, minus 1, vinculum 2, I call it minus also. Minus 2, minus 1, minus 3, minus 2 become minus 8. So this way, finally, you convert back to normal number. So this is the procedure has been shown there. You can see it, it really interesting. Here actually another example is shown where alternately there can be positive and negative non-vinculum and vinculum numbers. So negative numbers and positive numbers, they actually cancel out and it becomes very easy compared to the original addition. You just you can see practice yourself and it will be all right. Now, Vedic mathematics, some tricks are also given like this. Like you have to 15 square. So simply 1 into ekadikanu purvena. Purva is 1 here, 1 into 2, and then you square it simply 25. So 45 square is 4 into 5, 4 into 4 plus 1. একার যখন পূর্বে নাও 4 into 5 20 and then simply write 5 square 25. That way it is seen that big numbers like this 302 into 303 25, so 9150 26 91506 and then 25. So these are tricks, but actually from but actually there are rigorous mathematics behind this. Now here I start with some multiplication. Here I'm starting actually procedures I'm starting now. You can give attention to this. Multiplication of the pattern of 97 into say 93 or 987, 982 or 9985 into 9970, this kind of things. 9888 or 9997, these kind of things are handled. A base is defined as the nearest power of 10. You always remember that what is base? Base will be our nearest power of 10. So like here, I give the shortest example, almost like this, say base, which base 100. So 97 into 93. Normally what you do, you multiply with 3, all these things, and then you shift one thing, and then again multiply by 9. So much calculation you have to make to multiply this 97 into 93. But actually, how we do it here, this particular method is called multiplication near in a near a base by Nikilam method. Nikilam sutra. So 97 is how much short from the base? Base is 100. It is 03 base. We do not write 3 because it is number of digits. Number of power of 2 is here 2. Sorry, power of 10. 10 to the power 2. So we have to write 2 digits, remember. So 97 becomes minus 03 and 93 minus 07. What we have to do? Only multiply these two, and minus is plus, so it becomes 21. And then either you do 97 minus 7 or 93 minus 3. It becomes 90. So 9021 is my answer, just in one line. Aditi, do you follow it?
Yeah, I'm following.
Is it interesting? I get another bigger numbers. Basis 1000. So 997, I take the same example here for the two more. 997 and 993. In conventional method, it will be very big, somewhat bigger than the previous one. And then here we write similarly minus 003. Base is 100 here. Sorry, base is 1000 here. 1000 is 003 less than 997. Here also 993 is 007 less than 1000. So we write like that, and again we multiply, keeping in the same number of digits, 021. And here 997 minus 007 or 993 minus 003 is 990. So 990,021 my answer. Similarly, with 10,000, you see that number of increasing the more lines from the left, we'll be having more 9 in the first part and more zeros in the second part. You see, you keeping the number of zeros in 9997 or 0003, right? 9993 0007. Here also 0021 becomes the product, and 9997 minus this 7 is 9990. Here take another example, 9876 into 9987. So here 0124 and 0013. If you give the product, you can make the product in any fashion you like. 1612, and this 9876 minus 0013 is 99863. So 9863 1612 becomes my answer. So is it clear? But what is the algebraic background? Algebraic expression is like this. Here, this n is the base. Here n, capital N is 1000. Here capital N is 10,000, and so on. So this capital N minus A. This was already capital. Suppose this 3 is A here, and 7 is B. So this is n minus a is already given and n minus b is already given. We want to have a product of n minus a and n minus b. So I have to find n minus a minus b. How do you do this? By subtraction in the cross. This is already n minus a. I subtract b also from there. So it becomes n minus, this becomes n minus a minus b. And this plus ab. ab is here. This a and b, ab is here. And what is the shifting of these digits? This is this multiplication of n by 1000 becomes shifted 3 digits. Here, capital N is 10 to the power 4 means 10,000. Finally, this is n minus a minus b, and this is ab, and this is shifted 4 digits because n is 10 to the power 4 digits shifted towards left, and we write like this. So it becomes my answer. Is it clear? How
Yeah.
you could you relate it how it is happening with the algebra?
Yeah.
So here this is the example as I told. Here, I normal whatever algebra we use, we change the algebra here. So procedure also got changed. That is the thing. And procedure in this case, procedure becomes very easy. Now I give the example of above base. Above base is exactly the similar, only we have to add that thing. This is 103 and 107. It is also base 100. So it is 3 above the base 100. This is 7 above the base. So exactly same way. Also plus into plus is plus. So it becomes 21 and 103 and 107. And when you add either 103 plus 7 or 107 plus 3, 110, this is my answer. Similarly, this also I give the same example. 1007, 1003 becomes exactly the same one. This only have to write 1007 plus 3 is 1010, and this is also 21. To the 1010, this is also 021 to write. Here also 0021 to write 10,000. So it becomes 10,010, 10,007 plus 3 is 10,010, or 10,003 plus 7 is 10,010, and the 0021. Here also another example, 10,001, 1, 2, 3, and 5. So becomes 615 here. And this becomes 1, 2, 3 plus 5 becomes 10,001 to 8, and 1 to 8 plus 0, 6, 1, 5. Here you see that if the increasing number of more zeros increase, in the multiplicand, the result also will be having, in the first part also 1 0 will increase. Here see 1 0 1 0 1 0 0 1 0. Earlier even 1 1 0 it was earlier. So when 0 is increased, and also 1 0 is increased on the second part. Here also the similar exactly instead of plus instead of minus is plus now. N plus a into n plus b, n into n plus a plus b. This is already n plus a is there, n plus b is there. This is a and b. We make it here n plus a plus b, and with that we shift that with so many digits, and then we also add this ab. So this is about also. Mixture. If we have one less and one less and one more. How do I tackle that? Here I have given the example. 93 into 107. It is minus 0.07 and it is plus 0.07. When you add, when you multiply minus into plus is minus, so it is 49 will be negative. We write in Vimpulampam. And 93 plus 7 or 107 minus 7 becomes 100. And then 100 and this 49. When you leave that this thing, this is actually will be 9951. This will become 99 and this will be 51. Declare now the term of the or you can write 10,000 minus 49 if you do, it will be 9951. Here also I do. So 1013 into 993 plus 013 and minus 007. And the result is minus 91. We write like that. And 1013 plus 7 or 993, sorry, 1013 minus 7 or 993 plus 13 becomes 1006. And then 091. So ultimately 1006 000 minus 91. So that way it will become 1005 909 or 9996 0000 minus 21. It becomes 9995 9979. Here subtraction you can do, or you can do by Nikhil-Lavanavat's formula. Here 6 will be reduced to 5 and subtract from 9, subtract from 9, subtract from 9, and last one subtract from 10 becomes 9979, and this becomes 9995. Here I got it. Plus and minus is minus 21. So this is, and you know that. So here also n plus 1 n minus b, n plus a plus n plus a minus b minus a minus a. So you can see that algebra. Now the sub base part is there. So here you actually you go through that. It will not be difficult. I'll tell you. If any problem is there, I will give you. There is a. These are actually near to a sub multiple of that 1000 base. So it is near about 500. So we actually 500. How much is short from 500 is 17. Here also 3. Exactly the same similar way you do. But finally, the sub base has to be because if the sub base is there, we divide by 2. So here also, or you can do it by multiplication also, by base 100 you can consider in a similar fashion, but ultimately the 0 becomes added. So result becomes the same actually. So the here also above a base, above a sub base. Base is 1000, but sub base is 500. Or base is 100, but sub base is 500. So here you do the same procedure like that previous, but here you what we do? 517 plus 3, 503 plus 17 becomes 520, and 17 into 3 becomes 51. But finally, we 520, you divide by 2 to get 260. So here also it is there mixture now. It becomes a little complicated. So for the time being, let us leave, and if time permits, we will be. There are complicated cases are there. Here actually sub base becomes 250. Sub base is 250. 1000 divided by 4 is 250. So this into this sub base is similarly you do, and finally you divide by 4. And here division by 4 becomes fraction, and how do I tackle that will be very considering it will take some time to this thing. You try to understand, otherwise I will explain it later, other classes or privately. And algebra is like this. M into A. Here M makes it sub base. M into A minus A, and M into A, M into N minus B. M into N minus A and M into N minus B becomes Mn minus A minus B. This is Mn minus A and Mn minus B. So Mn minus A minus B becomes this like this, and it becomes AB. And this actually Mn, this M is here 1/4. So this we shift the digits, but what we how to do it? Subtract, divide also by that one. The M is 1/4, so 1000 is divided by 4. So here 232 is divided by. So this actually details. Now we come to another procedure. It is coming from Urdu Tirjak. Now, for that I first go. Let me go through that how they are conventional mathematics with how we do. Algebra. So suppose given to first first concentrate on algebra, it will be better to learning will be easier. given three digits number. So three digits number we can express in this way. That we already you must be knowing now. 100A plus 10B plus C. This is algebra. 100P
Yeah.
plus 100Q
Yes,
plus
sir.
R. In the conventional method, what we do? What I do? First, I take this is the we write in the lower. Suppose this is the lower number. The lower unit number we subtract with everything. Like whole number is subtracted. Subtracted. Multiplied by everything. So here everything is multiplied. Clear? Then everything second one everything multiplied by Q, the second digit. In the third one, everything is multiplied by P. And you shifted in the left, the second one shifted one place. So actually it is multiplication equal to multiply by 10. So it becomes actually 10Q, this 10Q. And for P also, we shift 2 digits towards left. So actually it is becoming 100P. And then we add. Whereas, your video is not there. Only my video is on. Some problem. Yes. Okay. Now, see Aditi, here in the Urdu Tijja government, what do you do? We group actually in different formats. We group actually to format. How there will be 10,000 place because 100 and 100 are there. Three digit number will have something in the 10 digits. 10,000 digits place. So how 10,000 is becoming? See, 100 into 100 is 10,000. So AP becomes my only source of 10,000 AP. We write 10,000 AP. And how the 1,000 piece will come? Either this 100 into this 10 or this 10 into this 100. Okay? So my 1,000 becomes AQ plus BP. And how the 100 will come? 100 will come either the 100 into this unit or 10 into 10 or this unit into 100 of this. Therefore, 100 becomes from AR, this A and this R in the list, B into Q and C into P. See, AR plus BQ plus CP. It becomes group into 100. And then this 10, how come 10 can come? 10 into unit or unit into 10. So this is therefore 10 into BR plus CQ. This B into R plus C into Q. And unit comes only one way, unit into unit, CR. And then finally it is added. And now interesting, this is actually, this method is found to be more efficient through research. Mean that the total procedure, if this multiplying this and adding so much and adding will be taking more process, more number of steps in the process than this. This Trijagam actually reduce the number of process. So that if circuits are designed using this Vedic mathematics procedure of Urdu Trijagam, all the devices will be more efficient. And considering the billions and trillions of devices throughout the world, there will be megawatt of power saved. Power will be saved when by using basic mathematics in the circuit. It's very interesting actually. So let me now learn the procedure. This one then, this one. To start with only 2 by 2. Like grouping, exactly the same way I've shown you the grouping. What is that done? The 3 into 5 is 15. So 5 we write here, 1 is carry. Carry we write 1 step below. You can also side by side you write these steps. So you can put a gap there. 4 gap and 3 you write, and 2 gap and 5. Maybe that no. There are procedures. So you write 4 gap 3 and 2 gap 5. Are you writing on the paper? You write with pencil. Huh? And write so this there'll be this So 3 into 5 is 15. 5 we write here, 1 we write slightly below left. Now the second digit is this one, cross. 4 into 5 plus 3 into 2 is how much? 26. So this 6 is here and 2 is below left. And 4 into 2 is 8, 8 we write here. Then you finally add 5. This is 6 plus 1 is 7 and the 8 plus 2 is 10. You follow it? Okay. Siddharth also follow?
Yes, sir.
Now come to 3D. 3D number many will be there as I've shown you by this already. This the AQ plus BP and AR plus BQ plus CP and BR CQ. And so the procedure is like this: 314 into 352. 4 into 2 is 8. 1 into 2 plus 5 into 4 becomes 22. 2 is here and 2 is another 2 is below left. Here 3 into 2 plus 4 into 3 plus 1 into 5. It becomes 23. 3 into 2 is 6. 4 into 3 is 12. 6 plus 12 is 18. 18 plus 1 into 5 is 23. 23 is 3 is here, 2 is here. This becomes 3 into 5 plus 3 into 1. 1 into 3. Because 18. 8 is here, 1 is here. And 3 into 3 is 9. So 9. You finally add all those things. Here it becomes 5 digits. 5 into 5 digits. It will be very big. So I've shown in the next one here. Same example. As I told, that if you create the gap, it will be more transparently shown. Because when you see even numbers of columns, so you place it in between. I'll show you, I'll tell you. Here it is 2, 3, 4, 3, 1 into 2, 3, 5, 6, 4, 2. First one is 1 into 2 is 2. Here I have shown here also. 2 into 5. This becomes 3 categories. This becomes 4 categories. This middle one is 5. 2 into 2 plus this 3 into 4. 4 into 6 plus 3 into 5 plus 1 into 3. Very big. Two into 2 plus 3 into 4 plus 4 into 6 plus 3 into 5 plus 1 into 3. See here. So I again doing the next one. See, this unit digit is coming from 1 into 2 is here. 3 into 2 plus 1 into 4, 10. 0 I write in between. See, I didn't write below anything. Therefore, I was telling that you write in a sparse method. So it is 0 and 1. Here it is 4 into 2 plus 1 into 6 plus 3 into 4 becomes 26. 6 is just below this middle one. 6 is below. So you don't lose any. When you lose the position, do not lose any position. Don't mix up position. 3 into 2 plus 1 into 5 plus 4 into 4 plus 3 into 6 is 54. 5 I write in between and 4 below this one. Previously. This is actually this 2 into 6, 2 into 4 plus 3 into 3 plus 3 into 6 plus 5 into 4. This one. That way it goes actually. Here I've shown that this method is used with vinculum. So these are more than 5. So we convert it into 4 and 4, 4. When something is more than 5 comes, actually this, if you write 5, 6, only 6 you convert into vinculum, it will become 6 and 4 into bar. So this will become 6 again. So to avoid that, here also we make this 300. I mean, it becomes, we express as 400 minus 44. So 4 and 4, 4. 4 vinculum, 4 vinculum. So this one you do. So here actually a lot of carries are there. You see that here only 2 carries are there here. Because many things will be cancelled. You practice this one, okay? Take it as an exercise. This one, although it is given, but you do yourself by writing it. Then if a problem comes, you tell me, okay? So that you learn procedure. I got your details for up to 3 digits, but this 5, 4, and take 5 and 4 digits that you can.
Yeah. Okay.
There was, I'll show you later because if we come out of the scene, it will break it. Now, I am giving a comparison between the different procedures. Multiplication procedures, different multiplication. 889 into 898, we do. Let me see first. Conventional method. Suppose this is given to you in your conventional method. I'm slightly mixing up because it is go to sequentially. Suppose you do not know anything, you do not know basic mathematics, all the other procedures, you only know whatever is taught in the school. You start with, you start the multiplication of 889 into 898. What you do? You did lot of big numbers, you multiply everything by 8, lot of money, this thing, this thing, this thing, this thing, this thing. Oh, sorry. Gone and parts. Yes. You do lot of calculation like this and arrive at 7112, isn't it?
Yes,
Then you
Guruji.
multiply with 9, again do lot of this in table 9, 9, 9, 8, 9, lot of 8001. And here you do similarly 8 into the 7 and 2. Finally, you add this. And you arrive at the. I will not show you because you do not know this. So for you, vinculum is not known. So now, how she Urdu Tirjakabham, this particular thing. Urdu Tirjakabham also, these are very high. So also you'll get a lot of problem. 8 into 9, 2 is here, 7 is here. 8 into 8 plus 9 into 9 becomes 145. So 5 we write here, 4 below, and 1 again below left. And again 8 into 8 plus 9 into 8 plus 8 into 9 becomes 208. 208. 2, 8 is here, 0 is here, 2. 8 into 9 into 9, 8 into 8 becomes 136. One could have written here also. 1, 3, and 6. 1, 3, 7. 8 into 8 is 64, 6, 7. Finally, add. Instead of that, since you know vinculum method, you convert it into vinculum. 889 becomes my 1 vinculum, 1 vinculum, 1 vinculum. Means actually, basically from 1000 here, see 1 in the fourth place, when in the thousands place means 1000. From there we are subtracting 111, so it becomes 889. So this is actually this procedure. And this is actually 102 short. We also vinculum method also we write 1 and 102. Here in vinculum method you write, you will see that numbers are very less and there is not requirement of any carry. -1 into -2 into 2. -1 into -2 is 2 and plus 1 into 0 is 2. 1 into 2 is this minus into minus is plus, so it becomes +2 and minus 1 minus 1 becomes 1. 2 plus 1 is 3 and this is of course 0, 3. this again becomes 1 into this, this becomes -2, and again become 1 into this -1, and this is 0, and this is 1. So it becomes minus 1 into 0, 0, 1 into -1 into 1 is -1, and -1 into -1 is +1, becomes 0. And after adding 1 into -1 plus 1 into -1 is -2. 1 into 1 is 1. And here, while clearing vehicular, the 322 as it becomes, and this 1 and 202, 1000 minus 202 is 798. Still, it is manageable than compared to this one. But Nikhil what it does, 889, we write base is 1000. So it is minus 111 shorter than that. 898, 102 shorter than that. So now the first part is very easy. 889 minus 102 is 787, or 898 minus 111 is 787. Now this is actually become very this slightly big. So what to do? Or could do another procedure. 111 is plus 11. 100 is the base plus 11, and 102 is plus 2. Here you write 11 into 2 is 22, and 111 into 2 is 113. Yeah. So 11322 is my result of 111102. It becomes easy to my earlier procedure written. But how to fit it here? Because there are only 3 digits allowed, 3 digits allocated for this one, but this is a 5 digit. So these 2 will be applying in the carry. You understand this? Let me stop for some time to let me know whether you understood this part.
Yes, Guruji, I understood, Guruji.
Okay? Because it is here, as per this Nikhilam method, base was 1000 here. So 3 digits are allocated for this one. But this is coming 5 digits. Here. Here the this multiplication procedure is easy, so no problem. So here you have to do this thing. 11 came below, and it directly go. So you tell me now, and this is one. Suppose now you use conventional method, but using vinculum. So here it like this. It becomes -2. With -2, if you add this thing, result becomes this. This 0, there's no result. So directly you come to this one and shift 2 digits. Becomes -1 and 111. And this also becomes 1 and minus this 3 vinculum, 3 numbers of 1 vinculum is 3 minus 1 minus 1. Finally, you add like this. Actually, exactly the same you get from here. Exactly the same thing you see. And then you clear the vinculum with this one. You now tell me, different person may have different opinion, but tell me which is the which you prefer in this case, with the best you want, easiest you in terms of your estimation. There are 4 methods. Of course, this is of course very big. I should compare this, and this one.
Guruji, like Nikhilam Navata is a bit easier for me.
Nikhilam Navata. This is the easiest. Generally, you are getting the position and everything here. Obviously, this is the easiest. Here is Vinculum. Of course, these are the very big. Both the Urdhva Jagabham and the conventional method, because the digits are very big. These digits are 8, 9, and so on, more than 5. So, either you convert into these smaller numbers, or you use Nikhilam now. Okay. So these are So for today, should we end here or this completes the multiplication?
Guruji.
So I for the 4 days. What I do, I to multiplication one day, and tomorrow is division. Another is there will be recurring decimal, and fourth there will be divisibility. I think that will be all right. Now, Aditi
Yes,
and
Guruji.
Siddharth, please teach rigorously. Go through this.
Guruji, could you please repeat, Guruji? I couldn't hear you.
You practice today,
Yes,
after tomorrow morning, and so on. Before the class, you practice all these things,
yes, Guruji.
Yes, Guruji.
and then let me know where you face any difficulty. I think should not be much difficulty here. In short, this actually I showed you. This
Yes,
becomes a
Guruji.
little complicated. Half in the digit becomes 50. Maybe we
Guruji.
keep it. You try to understand, otherwise we
Yes,
can discuss in another if we get time. Huh?
yes, Guruji.
Guruji, we can have Shanti Mantra now.
Yes, yes.
Okay. Aditi will recite Shanti Mantra.
Sarve bhavantu sukhinah, sarve santu niramayah, sarve bhadrani pashyantu, ma kaschid dukkha bhavet. Om Shanti Shanti Shanti.
Dhanyavad. We will stand up for national anthem.
Oh, yeah. Upside.
जनगणमनाधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड़ उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष माहे गाहे तव जय गाता जनगण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे जय हिंद. धन्यवाद गुरुजी. I think we will end
One more
recording
person was
today.
attending. I've seen one page was there.
Dhanyavad Guruji. It was very interesting.
Thank you very much. I'll stop recording.
What is your name?